Hello everyone. We will talk about our project, Default Zumo Project. My name is Kerem, Nevzat Kerem Ulusu. My fourth year in electronical engineering, and my friend Yiğit.
Hi, my name is Yeet, and today we are going to give you a presentation about the default Zumo project that we have uh, built with Kerem. So he will start with introducing you the project.
Thank you. I will start with introduction part. Our aim with this project is to program a Zuma robot that can autonomously scan the area and report the number of objects around it. It should operate in a given space and can be able to move in the area if it is necessarily. It should be able to scan different shapes, different scanning angles. This report outlines the progress that I have made in designing in the scenarios and implementing the codes that we have used in Lab 5. In this report, I will show design, construction, and software-wise progress. The goal of the project: first, autonomous scanning; second, programming in the Zuma robot; third, use of laboratory result; fourth, scenarios made with a robot; fifth, observing and interpreting the results. Design of experiment scenarios. To test the reliability of the Zuma robot, we had to create different scenarios. With the help of the given example in the default project file, we have created these samples. Thank you.
So I'm gonna try to explain the code. The first part we see in the right of the screen is basically the Zumo starter code that is given in LMS while we were doing the Lab 5. And so right below this code, there is a void setup code that the setup function is right below this code, and it is called once at the start of the program, and so it sets the LED pin as an output and the MZ80 pin as an input. So right below it, so could you please move to the next slide, Kerem? So right below it, there's a reflectance sensor code that initializes the reflectance sensor array. And so the code below it allows our Zumo robot to wait for 5 seconds. And this 5 seconds allows us to uh, calibrate our Zumo robot before it starts searching the area. The codes given below the reflectance sensor code, as you can see, unsigned integer most left, or unsigned integer left, or unsigned integer mid left, etc. It goes like this. So these codes are basically the helper functions that check the readings of specific sensors, and they return 1 or 0 based on the sensor value. So each function compares the sensor value with a threshold of 600 and returns 1 if the value is below the threshold, or 0 otherwise. So after these codes, we have our void turn right code. You can see it in the right and below the unsigned integer most right sensor. So this code actually sets the motor speeds to make the Zumo robot turn right while scanning the area. So it basically keeps turning right until it sees an object. And the code below it, the go function, sets the motor speeds to make the robot go forward, and it allows it to knock down an object after it finds it. So we have the real deal right after it. So our void loop So the loop function is the main loop of the program, and it keeps running. So first, it sets a finish time for the robot's whole process. In this scenario, we use 10 seconds. The position value variable stores the line position value obtained from the reflectance sensor's code. So our first if statement, if most left sensor, Kerem, by the way, could you please change the slides?
Yes.
Yeah, sorry. Here's our void loop again. I forgot to tell Kerem to change the slides, so I will explain it again. The loop function is our main function. It's the main loop of the program. It runs repeatedly. It sets a finish time for the robust process. In our case, we set it as 10 seconds. The position val under this while loop, this variable stores the line position value obtained from the sensors. So our first if statement is if most left sensor equals 1, mothers.setSpeeds minus 650 and minus 650, then we have a delay. So if the most left sensor detects an object, most left sensor equals 1, the robot sets its motor speeds to move backward, and turn right to scan the area. So if the most left sensor does not detect an object, the code checks the state of the MZ80 pin. If it is low, the go function is called to make the robot go forward and knock down the object. Otherwise, the turn right function is called again, and our Zumo robot keeps turning right until it finds another object. So our code then checks the value of MZ80 pin and updates the count variable accordingly. So if the pin is low and the state is false, it increments the count and sets the state to true. Otherwise, if the pin is high and the state is true, it sets to state to false. So after the process finishes, the motors are stopped with the motors.setSpeed0 function. And finally, the code blinks the LED pin for the number of knockdown objects based on the count variable. So basically, it works just like this. Thank you for listening.
Thank you. The last part of the conclusion. With the code we wrote, we have coded the Zumo robot. We observed and interpreted the working system of the robot as a result of the scenarios we made. As a result of observation, we have programmed a Zumo robot that can autonomously scan and report the number of objects around it. Visualize the result by shooting a video. Thank you, guys. Now we will show our video in the laboratory video. Thank you very much.
Thank you, guys.